Anjali, siapa yang mau share screen?
Kayaknya kamu aja deh pakai HP.
Oh, okay, okay. Wait a minute. Will set the timer first.
I have the timer, so I can remind you.
Okay. Um. Wait. Um. We will start now. Good afternoon, everyone. So today we will be discussing about the dental implant, which is planted in our mouth. So the dental implant, the material that are usually used for dental implant is like stainless steel, alumina, and then um, COCR alloys, and also zirconia. And this is the form of zirconia that we will discuss. That will have the further discuss about this. But the materials that some papers said that the materials that are usually used is stainless steel because it has low cost, and then it is easily to make. But other a lot of other papers also said that zirconia is also good. And uh, these are the mechanical properties of zirconia that will be explained by Anjali.
Okay, so the mechanical properties of zirconia, that is the reason why it is used as dental implants, because first it's because of its ductility, meaning that it can be easily reformed into other shapes that is suitable for every individual's needs, because every person will have a not different shape, maybe different sizes of teeth, and it will need to be adjusted by the implants. And the second property is the toughness. It has a high fracture toughness, meaning that it doesn't crack easily, so it can withstand the mechanical motions that is done by our mouth, and not easily broken. It is also strong. It has a high flexural strength, um, at a range of 800 to 1000 MPa. Next. Okay, these are also some people who has done some further research about the various materials. There is, we can see on the second row about the zirconia. It has the test done is uniaxial flexural strength and biaxial flexural strength, in which the number is, oh sorry, yeah, it has been studied for dental implants, and it is quite suitable. And there's the third row. I also studied zirconia as well as the last one, and it is quite favorable to be used as dental implants.
So that's all from us. Thank you.
Thank you.
Okay, thank you, Ezra and Angelia. So my critics is actually what I would like is not you don't jump immediately to the material properties. Yeah, for example, you choose dental implant. So explain first what will be, what so that the dental implant will be the function, right? The function. Explain first what would be the performance requirement for such application. For example, if it is used as a dental implant, it means it has to be able to endure chewing force. So you have to find what is the chewing force. When people chew normal chewing, then it has to endure what do you call it? This one grinding. Grinding sheet. If it is grinding means it apply shear force to the foot, right? So then the dental material has to be able to endure the shear stress as well. What will be then the usual number of shear stress? So in this case, you have also to find those information from maybe papers about or textbook on physiology of dental dentistry. Now from there, what could be the most appropriate material? So would it be metal? Would it be ceramics like zirconia? And why such material fit that requirement? So you have then to look at those material properties yang modulus. What about the where resistance means from the hardness? Yeah, you haven't mentioned about hardness quite uh, extensively. So please later try to make a small research on these things, yeah, and put into your final small report. Okay, in that logical step. So what is the application? For that particular application, so in your case, that will be dental implant. What will be then the functional requirement? It should be able to withstand the chewing stress. It should be able to withstand the shear during the grinding. It should be durable within the lifetime of the person. Lifetime of person, let's say 50 years, 70 years. Then what else? Based on that, what mechanical properties fit that requirement? The hardness have to be this. The strength has to be this, etc., etc. Then the material of choice is this. Then you confirm with the journal on that. So your approach now is you immediately jump like now you are making a review paper, but that's not what I intend. My intention like not like that. My intention is you will now act like an engineer. Then later after you find this is the material that would fit, then you check from your journal paper whether it really fit, whether it can be used. Yeah, of course you read first actually also. Yeah, the zirconia should fit, but why? Yeah, like now you cannot so the red thread benang merah can be really explained. Do you get what I mean?
Yes, sir.
Okay, so please later revise the small
Okay.
report. Yeah, thank you.
Thank you,
Let's
sir.
go to group 2 now. Andy, you may turn on your video and share your screen.
Aduh, aduh, aduh. Geser rapi-rapi dulu.
Ya, ya, ya.
Aduh. Mana ya? Aduh. Good good afternoon, Pak Dedi and my friends. So today I'm going to give in presentation about microchip implant. Actually with Tanita, but she is unable to come right now yet. So okay, let's. She helped me to find the contents a little. I haven't do the since the time is not enough, so I'll just give the website. Okay, so microchip implants. It is like identifying integrated circuit, or like RFD transporter encased in a silicate glass, and it is implanted uh, in the body of the human being. As you can see at the picture, that hand, there is a small thing right between the thumb and the jari telunjuk, and as you can see, the device at the upper figure, and the syringe is for the uh, to insert the microchip. So usually these microchips used for personal identification, law enforcement, medical history, medications, allergy, and contact, like that. And it contains ID number to differentiate people. So microchip implants, generally shaped like a cylinder. It contains small microchip, a biosafe epoxy resin, and a copper antenna wire coil encased in lead free borosilicate glass or soda lime shot 8625 biocompatible glass. Um, the microchips used like for both and animals and humans, and have no battery or a power source. Uh, so therefore, they are inert until they come within the field produced by a reader device, which implants communicate with over a magnetic field. I think that's all from me.
Okay, Andy. So my critics is similar, yeah, to the critics that I gave to group one. So my intention is not to jump directly to the material solution. For example, now here, actually the application is for subject identification, right? Either for human or for animal. Okay. So what will be the requirement? The requirement has to that implant be able to send or electromagnetic signal, right? So that you list first that requirement. Then requirement number two, that material has to be inserted in a safe way, such that the enclosure will not be toxic to the surrounding tissue. Third, from mechanical properties, since the material is inserted to place where there might not be any significant mechanical stress. Okay, so the toughness does not need to be very high, for example, etc., etc. Then from there, the choice of material, what is its choice? For the signal transmission, it has to be something metallic, right, and conductive as well. But so, for example, why can it not be immediately put like that metal? Why it has to be enclosed? Yeah, actually, this is not related to mechanical property. That is related more to biological property, yeah, material and biological tissue interaction, which you will learn with Pak Hollis later. But doesn't matter. You can already read about that. Then what are the other specification? So based on that, then the transmitter, the antenna should be something metal. Then the enclosure should not be something which is metal also. Why? If the enclosure is metallic, then it will function as a Faraday cage, right? You know Faraday cage? If something which is located inside a Faraday cage cannot transmit anything of electromagnetic, cannot receive and cannot transmit electromagnetic wave. So that is why the enclosure, the Okay, the enclosure could not be metal. It is made here from epoxy resin. Why you choose epoxy resin? Why not other ceramics, for example? That has to be clear. Is on the choice. Okay, similar like the group one. The dental has to endure chewing stress, has to endure grinding shear stress. In your case, what kind of mechanical property requirement does it need to have based on this particular application? You list first, maybe if you can quantify them. Then after that, what are the choices of material? And finally, the most optimal material is this. You understand? So for this particular task, I want you to approach from engineering point of view, from the application, going back, towards the beginning. Yeah, from moving from the end towards the beginning. Not like now. You are now basically just explaining what is there in the website, but not doing critical analysis and critical design. Okay, so this task is for all of you to try to learn how to become biomedical engineer, where you are asked to choose the best material for that particular application. Maybe you have another idea. Maybe what could be better than biosafe epoxy resin? Why does it need borosilicate glass? If the glass breaks inside the hand, would it not be disastrous, for example? Etc. etc. So think, yeah, use your imagination, use your intuition. You may also read the various scientific source, journal, papers, books to back up your report, yeah, your decision. Yeah. So finally, the conclusion: we choose this material, etc. Because the material mechanical properties like this, the toughness is like this, the Young's modulus is this, like this. So the emphasis for this chapter is still on mechanical properties, but yes, you could include in your analysis or your design the other material properties like electronic properties in your case, yeah, because this is a transmitter and receiver, an antenna, as well as maybe biological properties, yeah, the biological and tissue interaction. It's okay, even though it will be officially taught later by Pak Hollis. Is it clear, Andy?
Yes, sir.
Okay, yeah, clear. I I have this recording also. I will upload in YouTube and I can share, so later Grace can also see, yeah, this comments from me. Okay. Okay, that will be all for this session. Any questions from any of you?
Kan we